In this video, I'm going to solve exercise 12, page 93. We are given a parallelogram ABCD, any parallelogram, so we can draw it in any way you want. And we want to find, to construct the points E, F, G, and H satisfying the following. So this is any parallelogram ABCD. And first, I want to draw point E such that DE is 5 over 4 DA. So DE is equal to 5 over 4 DA. So as we explained previously, to do this, notice that first the vectors DE and DI are collinear vectors because they share a common point D, so they are confounded, DE and DA are confounded lines, so DE and A are collinear points. And since 5 over 4 is positive, then vectors DE and DA have the same sense. So if this is vector DA, DE would be in such a way having the same direction, same sense, but the magnitude is that of DA multiplied by 5 over 4. So you can measure this distance from here to here, multiply it by 5 over 4, and you get DE. So something like this. So accurately, this would be, so if we want to do this accurately, E would be this point. Second, we have the point AF equals 6 over 5 AB. So AF equals 6 over 5 AB. So this is vector AB. Okay. AB, notice here I drew AB having equal to 5 units. So this means that AF would be 6 over 5 times the length of AB, so it will be 6 units, according to my drawing. According to your drawing, it depends. So it depends on the length of AB. So you multiply the length of AB by 6 over 5, and you get the length of AF, and by the same argument, A, B, and F are collinear, and vectors AF and vector and B have the same sense, so F has to be here. Okay? And similarly, you can do the same thing for the remaining points. So we get point F. So this is F. You can do the same thing for G and H using the same exact argument, and you get the following points. This is part A. In part B, the first part of part B says, find EF as a linear combination of AB and AD. So I want to write EF as a number times AB plus a number times a real number times AD. So of course we need to apply Chase's rule. To do this, we have to look at the given. So in the given, I have DE and AF, BG and CH. I want to find EF, okay? So here, notice I have E with D and A with F. So I need to insert either letter D or letter A, or maybe both of them. So let's try the first one. For example, let's insert letter A to get AF, okay? So if we insert letter A, what do we get here? So by Chase's rule, let's insert letter A. So we get EA plus AF. So our goal here is to write everything in terms of the original points that we were given, A, B, C, and D, because if I do so, I can immediately write everything in terms of A, B, C, D, and therefore I can write everything in terms of vector AB and vector AD, okay? You will see now how. So AF, I already have it given here. It's 6 over 5 AB. However, EA, I don't have it, okay? But I have E only with D. So E, which is a new point that we plotted, I have it with D because I'm given DE. So I need to insert letter D again in order to get ED, or which is the opposite of DE. So again, in EA, I will insert letter D to get ED. So this is ED plus DA plus AF. So we apply Chase's rule again. Now we continue. ED is minus DE. Okay, so we are given that DE is 5 over 4 DA. So it means minus DE. This is minus DE. I'm writing it in too much details, but you don't need to do this. Plus DA plus AF. Now let's substitute. Okay. So DA, I want to flip it also to get AD because I want in terms of AB. So now let's substitute. Minus DE is minus 5 over 4 DA. DA is just DA. And AF is 6 over 5 AB. We're almost done because we want everything in terms of AB and AD, and we already have the A. Let's simplify here. Minus 5 over 4 plus 1 is minus 1 over 4. So this is minus 1 over 4 DA plus 6 over 5 AB. I'll just flip them. So this is 6 over 5 AB minus 1 over 4 DA. But minus 1 over 4 DA is the same as plus 1 over 4 AD. So we got EF equal to 6 over 5 AB plus 1 over 5 AD. So a number times AB plus a number times AD. So we wrote EF as a linear combination of AB and AD. Now, in the second part, we want to find HG as a linear combination of AB and AD also. We start in the same manner. So our goal first is to get rid of all the letters H and G because they are not from our original points A, B, C, D. Okay, so I want to write HG in terms of A, B, C, and D because then I could easily write everything in terms of A, B, and AD. Okay, so what do? Let's go back to the given and see where do we have H and where do we have G. So let's take one of them and start with it. So for example, back to the given. In the given, we have H with C here. So we have H with C. So I'll start, for example, by inserting letter C. Okay? Of course, all of these by Chase's rule. You should write that we are using Chase's rule. So I will insert, as we said, letter C. So this becomes, so I will insert here letter C. So this becomes HC plus CG. Okay? HC is minus CH. And we are given CH. And CH is, so I'm skipping some steps here, it's minus 6 over 5 CD. Okay, from the given. Now CG. Let's go back to the given. I don't have CG, but I have BG. So I need to insert letter B. So for CG, I will insert letter B. So this becomes CB plus BG. So I don't have a problem with CB because they are from the original letters on the figure. So I can easily write CB in terms of AB and AD. So I'll keep it as it is for now. And I will replace BG from the given. So BG from the given, it was 5 over 4 BC. Okay. Now, this is the same as minus 6 over 5 CD minus BC plus 5 over 4 BC because CB is minus BC. Let's simplify. So we get minus 6 over 5 CD minus 1 plus 5 over 4 is plus 1 over 4 BC. Okay, now remember we wanted to write everything in terms of AB and AD. So let's go back to the figure. So AB, keep in mind AB and AD. AB is the same as DC. So AB is the same as DC. AB is DC, okay? So this is 6 over 5 DC, so it's 6 over 5 AB, okay? So this is the same as 6 over 5 AB plus 1 over 4 BC. From the figure, BC is the same as AD, so BC vector is equal to AD vector. So BC is AD. So we were able now to write HG as a number times AB plus a number times AD. So we wrote it as a linear combination of AB and AD. Now the third part of the question, part B, is deduce that EFGH is a parallelogram. Notice from what we did before that both EF and HG are equal to 6 over 5 AB plus 1 over 4 AD. This means that EF is equal to HG. And we also know that the points E, F, G, and H are non-collinear. So we can conclude that the points form a parallelogram. Now, pay attention to the naming of the parallelogram. It's not EFGH. If you get confused, you can simply draw a sketch on the side. So I'll draw a sketch on the side or look at the original figure. So usually if you don't have a figure, you can sketch. So EF is equal to HG. This means that EFGH is a parallelogram. So EFGH or HGFE or GFEH or and so on. So this means that EFGH is a parallelogram or a point.